This video will continue our studying of the parabolas. That we're going to begin by looking at a regular parabola, that is y equals x squared, like the graph on the left, and then we're going to transition over to an inverse parabola, the one on the bottom right, where it's x equals y squared. Now take a moment real quick and just look at what's similar between these two graphs. Now you may notice that in both of them, the focus is always going to be inside the curve. So on the graph on the left, where the parabola opens up, the focus is above. Whereas the other graph, the parabola opens to the right, which means the focus is to the right. It's inside the curve. And in both of them, the directrix is outside the curve, so it's behind the parabola. So it's on the bottom for the standard parabola, and it's to the left in our inverse parabola. And that lattice rectum is still going to be that same length. The distance from focus to directrix is going to be the same as from the focus to those points on the parabola, that for the one that opens upwards, it's going to be the points left and right of the focus. And if instead, if we want to find where those points are going to be if the parabola opens sideways, again, it's focus to directrix, find that length. And then now, from the focus, you go up and down that same distance. So let's take a look at how the equations work out here. So we should be familiar with the basic vertex form of a parabola. Y equals a quantity x minus h squared plus k, where hk is still the vertex. Now here, the axis of symmetry is a vertical line going through that vertex, in which case the axis of symmetry is x equals h. To find the focus on the directrix, you need to find that 1 over 4a piece. And with the focus, you're going to add the 1 over 4a to the k value. And for the directrix, you're going to subtract that 1 over 4a. So you're going to get y equals k minus 1 over 4a for the directrix. Now the lattice rectum is a length, and lengths are always positive. So it's going to be the reciprocal of the stretch, and then make it a positive value. A way to write that would be 1 over the absolute value of a. Again, keeping in mind it's a distance, and distances are always positive. That's why we have the absolute value bars. Now, what if instead it's an inverse parabola? So it's going to look a little bit different, but you're going to see a lot of similarities in the equations. Instead of y equals something x squared, we're going to get x equals something y squared. So if we put it in all the transformation form, it's going to look like this. X equals a times the quantity, y minus k squared, plus h. Now, there's a couple things that are different and a couple things that are similar. First off, they both have that same stretch of a. And they still have a vertex of hk, but notice where the hk is now. Inside the parentheses, where we usually see the h, that's where the k is. And the h is actually outside the parentheses now. So when you have these inverse parabolas, that vertex, h value is going to be outside the parentheses, and it's going to be exactly what number that shows, whereas inside the parentheses, the opposite of that value is going to be the k. Now, instead of having a vertical line for an axis of symmetry, it's now horizontal. So now it's going to be y equals k. The focus, you're still going to use the 1 over 4a, but notice now the focus is to the right. To get it to the right, we're going to have to add the 1 over 4a to the h value. So that's going to be the coordinate h plus 1 over 4a, comma k. And because the directrix is to the left, that means we're going to subtract it. So x equals, vertical line, h minus 1 over 4a. Now the lattice rectum is still going to be that reciprocal of the stretch factor, so it's still going to be 1 over a, and then the absolute value. Now if you need to finish copying this, pause the video. I'm going to go ahead and move to a couple examples now. So let's take a look at this first example. Notice it's not in vertex form. Instead, x squared plus 4y is equal to 8x minus 12. Now one of the things I'm going to have to do is find vertex form, but before I can do that, I want to think, what type of parabola are we looking at? Is it the traditional parabola, or is it an inverse parabola? And the way we're going to do that is we'll look at what's squared. Here, the only thing squared is x. I have an x squared, which tells me this is going to be that standard kind of parabola, those that open up or down. Now, I'm not going to be really sure yet. I see it's positive x squared, but it's also grouped with the 4y. And as soon as I start moving things across, the direction is actually going to change on this. So in this case, I want to keep the 4y by itself because the standard, or the vertex form of a parabola that has a x squared is y equals a quantity x minus h squared plus k, meaning y needs to be by itself. So to begin this, I'm going to complete the square, and I'm going to move the x squared to the other side. Now I actually see it's a downwards parabola, right? It's a negative x squared, which means this parabola is going to open down. But we're going to still complete the square, knowing that we've got some type of standard looking parabola. So to begin, I'm going to group my x values, and I'm going to factor out that negative 1. In order to be able to complete the square, it's got to be a 1x squared. So if I factor out the negative, and I'm taking out of both my negative x squared and my 8x, so factoring out a negative, I get the 4y equals negative quantity, x squared minus 8x. Now half the b value, half of negative 8 is negative 4, and square it. We then close the parentheses, bring down the minus 12, and now it's time to balance the equation. If we've subtracted a negative 4 squared, then I need to add to balance it out if we're going to do it on the same side. In which case, if I add the quantity negative 4 squared, if I add a 16, I've balanced my equation. Subtracting the 16 and adding the 16 doesn't change the actual equation, it just changes the form. Now let's go ahead and finish completing the square. 4y equals negative, and then x squared minus 8x plus that negative 4 squared can be rewritten as the quantity x minus 4 squared. And then the negative 12 plus the 16 is just positive 4. Now we're almost there, but we've got to finish getting y by itself. We need to isolate the variable, which means we're going to divide both sides by 4, in which case y equals the negative 1 times the quantity x minus 4 squared becomes negative 1/4 times that quantity, and then 4 divided by 4 is going to be 1. So when we divide everything by 4, here's our vertex form. Y equals negative 1/4 times the quantity x minus 4 squared plus 1. In this form, we can take the hk. The opposite of that parentheses is going to be my h, and then the case at the end, in which case this vertex is going to be sitting at 4, 1. The axis of symmetry would go through this vertex, in which case x equals 4. Now to find the focus in the directrix, I need to do my 1 over 4a piece. 1 over 4 times, and I look at my vertex form, it's negative 1/4. 4 times negative 1/4 is going to be negative 1, and 1 divided by negative 1 is negative 1. So we'll add this to find the focus, and then subtract it to find the directrix. Now this is going to be above and below the vertex, which means we're doing it to the k value. So for the focus, it's 4 comma 1 plus a negative 1, which becomes 4, 0. And then for the directrix, y equals 1 minus a negative 1. The double negative becomes a positive, and this gives me y equals 2. Now because this parabola opens downwards, the directrix is actually above, and the focus is below, so that it stays inside the curve. Now the latus rectum is going to be the reciprocal of that stretch. Now the 1 over the negative 1/4, and keep it at absolute value, making it positive, is just going to give me 4. So let's go ahead and graph what we see. Make sure you have your labels and scale on your axes. And let's plot this. Let's start with the vertex. We know the vertex is at 4, 1, and the focus was 1 unit below at 4, 0, which means the directrix has to be 1 unit above at y equals 2. Again, the vertex is always in the middle. Now for the length of the latus rectum, we get that from the distance of focus to directrix, which is 2 units, which means we go 2 units to the left of the focus and 2 units to the right of the focus to find that latus rectum of 4 units. Now we're ready to draw the parabola. Here it is. It's through those 3 points, not including the focus. The focus is always inside the curve. Now let's try another example. Let's look at one of our inverse parabolas. So here I've got negative 8x plus 2y squared plus 8y minus 16 is equal to 0. Now I may have given it away, but what type of parabola is this? Well, looking at what's squared, this time it's y squared. Now if it's y squared, that tells me this is going to be a sideways parabola. This is the inverse parabola. So we know it's going to be some type of either opening to the right or left. So now when we want to get vertex form, we're going to keep x by itself and push everything else to the right-hand side. In which case, to get my completing the square, I'm going to start by subtracting 2y squared from both sides, subtracting 8y from both sides, and adding the 16 to both sides. Push those 3 things to the right-hand side. Leave the negative 8x where it is. Now, because the negative 8x and also that negative y squared, I could go ahead right now and divide everything by negative 1 and make it a positive x and a positive y squared, just make it a little bit easier for me. So I'm going to do that now. To get going with completing the square, I'm going to factor out a 2 from my y values, and that's going to leave me a 1y squared, which I need. So let's go ahead and do that. And then if I factor out the 2, 2y squared divided by 2 is a y squared, 8y divided by 2 is a 4y, and then half of the 4 is a 2, so I'm going to put plus quantity 2 squared. Close the parentheses, bring down the 16, which again is now negative 16 because we factored out that negative 1, and then I need to balance my equation. If I've added 2 groups of 2 squared, if I've added 2 groups of 4, then I need to subtract 2 groups of 4 at the end to balance the equation. Now, if I rewrite it, I get 8x equals 2 times the quantity y plus 2 squared, and then minus 16 plus 8. That's going to be negative 24. I'm sorry, I said negative 16 minus 8. Sorry, it's negative 24. The last step now was to divide everything by 8, so we can get x equals. If we divide everything by 8, we're going to get 2 eighths, which becomes 1/4, times the quantity y plus 2 squared, and then negative 24 divided by 8 is negative 3. Now there's my new vertex form. x equals 1/4 times the quantity, y plus 2 squared minus 3. Now with this one, you got to keep in mind when we find the vertex, this is h right here. And the opposite of the piece in the parentheses is going to be my k. And it's a little awkward to do this a couple times, but once you do a few of them, you get the hang of it. When it's the inverse, h is on the outside, k is the opposite in the inside of the parentheses. In which case, this vertex is going to be -3, -2. Now the axis of symmetry is now a horizontal line, and it goes through that k value, y equals -2. To find the focus in the directrix, we need to find that 1/4a piece. And if we do this, we get 1/4 times 1/4. 4 times 1/4 is going to be 1, and 1/1 is 1. To find the focus, we're going to add it to get it 1 unit to the right of the vertex, which means we're going to have to add it to the h value. So -3 plus 1 comma -2 is going to be my focus, or -2, -2. The directrix is going to be to the left, which means we're going to subtract it, in which case x equals -3 minus 1 gives me x is -4. And that vertical line is going to be the directrix. Now the lattice rectum is again the reciprocal of the stretch and made positive, which is going to be 1/1/4, or 4. So let's go ahead and plot this up on the graph. Start with your vertex. We know the vertex was at -3, -2, and the focus is 1 unit to the right, which means the directrix is 1 unit to the left of the vertex, and that's that vertical line, x equals -4. Now the distance from directrix to focus is 2 units. Again, from the furthest point to the line, 2 units, which means to find the points that make the lattice rectum, we're now going to go above and below the focus. So instead of left and right of the focus, we take that same distance, but now we go up and down from the focus. So if directrix to focus was 2 units, we're going to go 2 units up above the focus and 2 units below the focus. Those 3 points become the parabola, and here we go. Again, notice that the focus is on the inside of the parabola, the directrix is on the back side, outside the parabola. Okay, let's try one more example. Now this one, if you're doing it on the handout, you're going to notice is actually number 5. I've skipped the other ones for a moment. Let's go ahead and plot what we know so we try to figure out what we have going here. So to figure out what kind of parabola, I'm going to plot these 2 points, or these 2 pieces of information. I've got the vertex, -2, 1, and I've got the directrix, which is that vertical line, x equals 1. What type of parabola is this? Well, if the vertex is to the left of the directrix, that means the focus is going to be to the left of the vertex, in which case this is a sideways parabola. This is going to look like this, and it's going to open to the left. So let's plot in what we know. The axis of symmetry would have to be y equals 1, because it has to go through the vertex, which means if we go 3 units to the right to find the directrix, we'll go 3 units to the left to find the focus. And there's the focus. It's at -5, 1. Now that's a total of 6 units from directrix to focus, which means we can go up and down 6 units from the focus to find those points that make up the lattice rectum. These 3 points are going to be my parabola. Now because we went 6 units above and 6 units below the focus, that total length is 12 units for the lattice rectum. Okay, let's put this into vertex form. Now it is an inverse parabola, so we want to use x equals 1/a times the quantity y minus k squared plus h. Now keep in mind the hk, that -2, 1, they're in different places than where we're used to seeing them. H is on the outside of the parentheses, the opposite of k is inside the parentheses with y. Now this parabola also opens to the left, which means this is going to be a negative, and then 1/a becomes 1/12 times the quantity, y minus 1, which is the k value, squared, and then bring down the h, which is -2. This equation is x equals -1/12 times the quantity y minus 1 squared minus 2. All right, hopefully this helps get you through the notes today.